really good to be with you this evening, and I certainly enjoyed that music. I hope you did too. And I want to continue the theme really with what really is worshiping God. You see, when we worship God, to worship is to bow down, and that can either mean a physical bowing or it can mean bowing our will to God's will. And that necessarily means being in submission to Him and being willing to obey Him in His command to go and make disciples of all nations. We certainly want to do that. And when we are preaching the gospel, there are objections that come up to it. People will say, no, you can't believe the Bible because, and let's be honest, the primary objection is because who believes in Genesis anymore, right? That hasn't science disproved that Genesis creation, nobody believes that God really created, or certainly not that He created in 6 days and so on. Millions of years of evolution, that's what science tells us, allegedly. But what I want to show you this evening is that when you really understand science, it confirms biblical creation. That is, science agrees with what we would expect given what the Bible teaches in the book of Genesis. And so what I'd like to do this evening is I'm going to cover a few different fields of science, and we're going to see that in all cases the evidence is consistent with biblical creation. Really, we all have the same evidence. People sometimes think that creation versus evolution is all about who can get the most evidence. We all really have the same evidence. Creationists and evolutionists have exactly the same evidence. You realize that? Because we have the same world. And we have access to the same fossils and access to the same DNA patterns. And I look at the same stars and galaxies as my secular colleagues, but we look at it a different way. We have a different way of thinking about things, which you can think of sort of like mental glasses or a mental lens through which we view the universe. And my secular colleagues, when they're looking at the world, they're thinking in terms of naturalism. Nature's all that there is. There's no God. Millions of years of slow, gradual evolutionary processes produced all life on earth, millions of years of suffering, extinction, killing, disease, and so on, leading up to human beings, and human beings being sort of the pinnacle of evolution. Well, when I look at the world, I look at it from a biblical perspective. The history that the Bible gives us, which we summarize with the 7 C's of history there. I believe that God created the perfect world, a world that He Himself called very good, but that world has been tainted by sin. God gave Adam dominion over that world, and because of Adam's rebellion against God, God rightly cursed the world and Adam as a result of his disobedience. And so now things are not so good, not as good as they were anyway. God's removed a little bit of His sustaining power. But what I want to show you is that when we look at the world from the perspective of biblical history, creation, corruption, catastrophe, the worldwide flood, the confusion of tongues at Babel, and so on, Christ Himself, God steps into history, takes our place on the cross, we can have confidence that this is true history right here. What the Bible gives us is the true history of the universe, and therefore we can expect in the future the 7th C, the consummation of all things, where God restores paradise. That's yet to come. And we can only take part of that if we've received Christ as our Savior. But I want to show you that the evidence confirms the biblical worldview. I'm going to cover 3 different fields of science this evening briefly. That's really all we need to show you that the basics of science confirm biblical creation. We're going to talk about genetics, which is the study of how traits are passed on from one organism to the next, involving things like genes and DNA and so on. We'll touch on information theory briefly, it turns out to be a very powerful field of science that confirms biblical creation. And then we'll talk about geology, earth science, things like rock layers, and we'll deal with fossils as well, and the age of the earth as well. So I'm going to start with heredity, genetics, the study of heredity. And so that's the study of how traits are passed on from one organism to the next, how animals change over time. Do animals change over time? That's my first question for you. Do dogs change over time? Yeah, dogs change over time. What did they change into? Dogs, yeah. See? It's not that hard, is it? Dogs do change into other dogs. Now, this isn't evolution in a molecules to man sense, is it? Some people would say, well, there you go. Evolution just means change. They changed. Well, okay. We all agree with that type of change. But that's what I'd expect on the basis of Scripture, right? Because the Bible does not say that God created animals to reproduce exact clones of themselves. No, it says He made them after their kinds. Isn't that right? And that's a phrase that's used 10 times in Genesis 1, after its kind or after their kind. We better take that seriously, that there are discrete kinds of organisms. So yes, dogs can change quite a bit from one generation to the next. God has built in a lot of variation into the dog kind, but they always remain dogs. What were they? Dogs. What are they now? Dogs. What will they be? Dogs. That's not evolution. That's just dogs. Okay? You can even get different species in some instances, by the way. The Bible doesn't use the term species. It uses the term kinds. And kind is not exactly the same as a species. We need to keep that in mind. Species is a modern, man-made term. The Bible uses the term kind, or bara min, created kind. And it is possible to get more than one species. This group of mosquitoes goes off and lives in a cave for 100 years, and when they bring them back out, due to genetic drift, they can't interbreed with other mosquitoes. They're classified as a different species, but they're still mosquitoes. They're still the same kind, and there'll always be mosquitoes. That's the way it works. See, I find that evolutionists often misrepresent what it is that creationists teach. This is not what the Bible teaches. The Bible does not teach fixity of species. But you'll find evolutionists sometimes will say, oh yes, creationists believe that God made all the species on earth just as we see them today. And some have even gone so far to say, and even in their current locations. Well, that is not what we teach, because that's not what the Bible teaches. I don't believe that all the animals are exactly the same today as they were at creation. I don't believe that there were poodles in the Garden of Eden, right? Because it was a paradise. So you're not going to have poodles in there. Not at all. So I don't believe in this fixity of species. Things have changed, and not for the better, okay? This is what I believe, something like this. You see, God created certain kinds at the beginning, and they have diversified. They've changed a bit over time, and they've split into different breeds. And in some cases, you even get different species, but they're still the same kind, and they remain the same kind. Variation within a kind is what the Bible teaches, and that's what we as creationists who are trying to be faithful to the text of Scripture would teach. And so, yeah, you can get lots of different breeds of dog from just two. You don't need 2 dogs on Noah's Ark. That's all you need. And you can get all those different breeds later. Not a problem. And so poodles are just one of these horrible little offshoots up here at the top. And not a problem. Of course, some kinds have gone extinct. There have been some kinds where certain variations have gone extinct, but other variations remain, such as the elephant kind. We still have elephants today, but mammoths, which we think are the same kind as elephants, those are gone. That particular variation didn't make it for whatever reason, ultimately because of sin. That's why things die. So this is what we actually teach, and I find that evolutionists might have a more difficult time defending against that. Now, of course, what evolutionists teach is that all kinds, there really aren't separate kinds, because all organisms are related by common descent. That's the neo-Darwinian view of evolution. And so a single-celled organism allegedly evolved from random chemicals, and then it diversified and split into all things, including you and me, and you are related to a turnip if evolution is true. And one time I said that I was speaking to a group of evolutionists, actually, and I mentioned that, and at the end, one person came up and said, weren't you kind of making fun of us there at the end and, saying, we're related to a turnip? And I said, isn't that what you believe? He said, well, yeah. And I said, well, there you go, right? I mean, I'm not poking fun at it. If it sounds ridiculous, maybe you ought to reconsider what you believe. Well, anyway, to know which of these is true, or at least which one of these is compatible with science, we need to know something about DNA, which is a very long molecule that occurs in the cells of your bodies, and it looks sort of like a twisted ladder, and on the rungs of this ladder are chemical base pairs, chemical nucleotides, and there's 4 different types of them, and they're always abbreviated by those 4 letters that you see there, and the C's and the G's always group up, and the T's and the A's always group up, but they can be arranged in any order. And the way they're arranged actually spells out information. It actually spells out the instructions on how to make the proteins that make up you. And the reason that you are a person and not a cabbage is you have instructions for a person, and a cabbage has instructions for a cabbage. And I'm sure you're glad that there are some differences there. It's really like you could spell help with Morse code with beads on a rope. And it's the same kind of thing. Just by the way they're arranged, you can spell out information. Theoretically, you could write a book in DNA. Okay? And, I think it's amazing because we think we're sophisticated. We get all this information on a DVD or a Blu-ray, right? I mean, how much information can you get on a Blu-ray? Well, God put all the instructions to make you on a molecule. That's pretty neat. That's pretty amazing. And the encoding mechanism is just phenomenal. I mean, we thought we'd cracked it. We sort of understand how proteins are built and so on, but we're now finding it's much, much more complicated than we thought. Much more complicated. You wouldn't believe it. I get to talk with some of my colleagues. I'm not a biologist, but some of my colleagues at ICR, PhD biologists, and they start telling me about some of the complications that have been discovered, and it's overwhelming. It's amazing, the machinery that is involved in this. It's an engineering, it's an amazing engineering feat. Now, to make things even more complicated, you have 2 sets of DNA. You get 1 set from dad, you get 1 set from mom. And a section of DNA that controls a particular trait is called a gene. And so you have some people have genes for blue eyes and others genes for brown eyes and so on. And it's the combination of the two genes, one from each parent, that determines your traits. And so here it is with blood type, for example. And so if you get, for example, the A gene or the A allele from mom and you get the O from dad, your blood type is A because A is dominant and O is recessive. Maybe you remembered on this in high school. Or you can get AB by getting the two, they're codominant. The only way you can get blood type O is to have the two recessive genes, one from each parent, which is actually a very common blood type because the O allele is just very, very common in the human genome. Now, the thing that I find interesting about this is that if your parents have this particular combination, let's say mom has blood type A, and it's what they call the heterozygous A, where you have the O and the A, and dad has blood type B, and it's the heterozygous B with the O and the B, the children could have any possible blood type. They could have A, like mom, they could have B, like dad, they could have AB, which neither parent has, or they could have O, which neither parent has. That's pretty neat, because what that tells me is that you can have traits that neither of your parents have. That's kind of neat. You probably have a lot of traits that your parents do have, just because of the way it works out. But because you have a unique combination, you can have unique traits. Unless you have an identical twin, you have a unique combination of DNA. But you still got the information from your parents, you see. Isn't that an ingenious system, the way that works out? And you see, because God did it that way, because God did it in terms of combinations, the amount of variation in human beings is astonishing. From just one married couple, you could get more unique human beings, theoretically, if we'd not sinned and they lived forever. You could get more unique human beings than there are atoms in the universe. That's the amount of possible combinations. And it's not even close. It's way more than the number of atoms in the universe. So, pretty amazing. So that's why you can have traits that neither parent has. I have brown eyes like my mom, and my brother has kind of green eyes like my dad. My sister has blue eyes, traits that neither parent has. I used to tell her she was adopted. She didn't believe me, though. And I was just funning with her. She knew that. But anyway, but now that you know how that works. Now here it is with skin color. We basically all have the same skin color, brown. It's just a question of how much. How much of that pigment, melanin, do you have in your skin? And this is simplified, but basically this is how it works. If you have these type genes up here, then you're going to have lots of melanin, very dark complected. If you have these genes down here, you're going to tend to be light complected. Now, if you're down here in this box and you get married to somebody in that box, your kids are going to be in that box. And you can see why. It's because only the lowercase letters are available. That's it. And likewise here. And in same way here, if you get in this box and it's little A's and big B's, and you get married to somebody with little A's and big B's, your kids are going to have exactly that combination. But the thing that's interesting is if you're off axis, if you're over here, for example, then the children, and you get married to somebody in that box, the children could have any shade of skin from very dark to very light immediately in one generation. And so we think that Adam and Eve probably had that color skin. There's other possibilities, but that's one way to do it. That would make a lot of sense. And so their children could have been from very light to very dark in one generation. It makes a lot of sense, doesn't it? And there are places in the world today, too, where that still happens. There are places in India, for example, where people have that combination. And at the same dinner table, you have very dark complected, very light complected. Now, we're going to take a look at dogs because we can see all the different variations in the dog kind, and it's phenomenal. Because dogs reproduce relatively quickly, we can see how all this works. But you see, God has built tremendous variation into the dog kind. So the first dogs that God created had, lots of heterozygous genome, big A, big B, little b. And in one generation, you can get all kinds of variety of dogs. But you see, they still got the information from their parents, just like all the information you got to make your traits you got from your parents. You have a unique combination, but you got the information from them. Now, if evolution's true, then something like a bacterium eventually became something like a horse, right? Through reproduction, through mutations and natural selection. Now, a bacterium has some instructions in its DNA, the instructions that are needed to make the bacterium. And a horse has a lot more instructions in its DNA. It's not just that it has more DNA, although it does, but it has more instructions in its DNA. It has instructions that the bacteria do not have. A horse has instructions to make ears and eyes and legs and a tail. Bacteria do not have those instructions, and therefore they don't produce those traits. That's easy. So it seems to me that if evolution is true, then at some point information must get added to the DNA. Isn't that obvious? I mean, if you're going to turn this into this, and this has a lot more information than this, at some point information has to go up. So evolution is all about an increase in information in the DNA. Now, that's not the only thing that would be required, to be sure. There are other problems, I think. Even if you could get information, extra information added, there are problems of irreducible complexity where all the parts have to work together or it fails, things like that. But at the very least, you have to increase information in DNA. And I'm beating that to death because I want you to get it. Evolution is about an increase in information in your genome, in the DNA. And that's important because in science, what we observe are decreases in the information in DNA. Yes, the scientific processes that we actually observe in the present are always downhill or perhaps neutral. We don't observe brand new information being added to the genome. Isn't that interesting? So what that means is the types of changes that we see in organisms are not the kinds of changes that could ever turn bacteria into a horse. Not going to happen, based on what we observe in the present, based on good observational science. One example of this is natural selection. People will say, well, you believe in natural selection? Of course we believe in natural selection. It's observable in the present. It's good science. It's true. And it's the opposite of evolution. It's kind of ironic because Darwin thought if he could convince people natural selection is true, they'd buy into evolution. They're opposites. Here's why. And I'm going to illustrate this with dogs again because we can see how dogs, the genome works there. And so suppose you have two dogs, and suppose that these dogs have one gene for short fur and one gene for long fur, and suppose those genes have a combined effect, which some genes do, such that these dogs have medium-length fur. Okay, now this is simplified, but the basic genetic principles here are true. Now, if these dogs fall in love and get married and have offspring, some of those offspring are going to get the short gene from mom and the short gene from dad, and they're going to have short fur, right? Some of the dogs are going to get the short gene from one parent, the long gene from another. In fact, statistically, 50% of the offspring would have that combination. And so they're going to have medium length fur just like their parents. And then some dogs are going to get the long gene from mom and the long gene from dad, and they're going to have very long fur. Now, so you see what happens. In one generation, you're able to produce a lot of variation within a kind. Not evolution, though, because we started with dogs, we ended up with dogs. There's no new information. We started with information for short and long. We ended up with information for short and long. Not evolution, not yet. Well, where does natural selection come in? Well, let's suppose the environment gets very cold. Let's suppose there's an ice age that comes through, and these dogs, well, what's going to happen? The dogs with the longer fur are going to be fine. They're well insulated against the cold. The dogs with the shorter and medium-length fur, they don't do so well in a cold environment, right? And so, sadly, they die. I didn't say natural selection was nice. I just said it was true. It's something that's true in a cursed, fallen world. Now, what happens is the dogs that survive are the ones that have the longer fur gene, right? And so what happens is they meet up with other dogs with the longer fur gene, the only other ones that have survived. And when they have offspring, what are the pups going to have? Long fur, because you see, that's the only combination that's left. They can only get the long gene from each parent. Are they going to produce short-haired dogs or medium-haired dogs? The answer is no, because that information is gone. Now, this is a great example of adaptation. The environment got cold, and lo and behold, the ones that survived were well suited to that environment. That's an example of a type of adaptation. It's a great example of natural selection, right? The animals that survived are the ones most suited to their environment. So it's a great example of these things, but it's a very poor example of evolution because no evolution's happened. We started with dogs, we ended up with dogs. And in fact, it's the opposite of evolution because we haven't gained any new information. We've actually lost information. We've lost the information for short fur, right? It's gone. If there's a heat wave, will they ever go back to having short or medium-length fur? No, they're just going to die because that information's gone. Now, if we started the experiment over again and we had all three varieties of dogs, and let's say this time the environment gets very hot, well, now what's going to happen? Well, now the dogs with the longer fur don't do so well, right? And so they die. The dog that has the shorter fur, he does better in that warm environment. And so he goes on and finds other dogs that have survived because they're also well suited to that environment. And you end up with lots of dogs with the short fur that are well suited to that environment. Not a problem. Again, it's a great example of adaptation, great example of natural selection, but it's not evolution because it's in the wrong direction. Evolution's supposed to add brand new instructions to the DNA. This process has lost instructions in the DNA. Namely, it's lost the instructions for the long hair, and by implication, medium-length hair as well. So this is how we account for at least partly how we account for adaptation of animals within their particular environment. And we find, lo and behold, that dogs that end up in the colder environments tend to have the longer fur. Those in the hotter environments tend to have the shorter fur. Otherwise, they wouldn't be there. They wouldn't be able to survive. And so we don't need evolution to account for dogs. We can just take a look at the biblical account. We know that there were 2 dogs on Noah's Ark. They're part of the unclean kind, so they would have been just 2 dogs. And when they get off the ark, they leave and they disperse away from the mountains of Ararat, where the ark landed, and they carry certain traits with them. And some traits are conducive to survival in a particular environment, others are not. And if the traits are not conducive to survival in that environment, they tend to be eliminated because the animal dies. And so lo and behold, we find that dogs that end up in cold climates tend to have thicker, longer fur, and those in the hotter environments tend to have thinner fur, because if they weren't, they wouldn't have survived. And if the dog's smart, maybe it goes to the environment that best suits it. That's another possibility, at least for animals that are mobile. And so you see, this is how we account for the different breeds of wild dogs that are out there. It's just the variation that God has placed in the dog genome and natural selection kicking in. And basically, the dogs that are not well suited to a particular environment get killed off. It's not a problem. It's perfectly compatible with creation, and it's the opposite of evolution, because we haven't gained any new information. We've lost information. Now, my secular colleagues would say, but Dr. Lisle, it's not just natural selection, it's natural selection and mutations that are evolution, right? So we got to talk about mutations. A mutation is a copying mistake in your DNA. You think of it as a typo in your DNA. And so here it is. Here's one type of mutation that could occur. You have dogs with genes for 4 normal legs, which all dogs should have. But there's a copying mistake, and so some of those instructions get lost, they get garbled, and you end up with a dog, his legs don't form properly because he's missing some instructions, and so you have a dog with short, stubby little legs. And that can happen in nature. There are examples of that. Now, if you think about it, a dog that has short, stubby little legs, he's not going to do so well in the wild, is he? I mean, a dog like this, he can't run very fast, he can't catch anything, he's more likely to get caught by something himself, right? So he's not going to do so well in the wild. And so we find that mutations, to some extent, tend to be eliminated in nature, right? Because, in fact, some mutations are fatal. And if you have a fatal mutation, you're immediately dead, and that mutation is not passed on. So those ones are immediately eliminated. And then some of the ones that are just mildly inconvenient, some of those can be passed on, but some of them are eliminated because they have deleterious effects on the organism, generally. But some people like dogs with short, stubby little legs because they can't jump up on you as much. And so people will encourage mutations that they like in dogs. And they'll take this poor little thing, and they will feed it, and they will take care of it. And this dog doesn't have to survive in the wild because he has a human caretaker who spends millions of dollars trying to keep him alive. Okay? And so people will take dogs with short, stubby little legs and breed them with other dogs with short, stubby little legs, and you end up with lots of dogs with short, stubby little legs. And but again, it's not evolution because we haven't gained any new instructions. Not at all. In fact, we've lost instructions at an alarming rate in some of these cases. And that's why domestic breeds of dogs are full of mutations. There are a lot of purebred dogs that just really wouldn't do well at all in the wild. Some of them couldn't survive at all in the wild because their mutations would cause problems for them, but because they have a human caretaker, they're able to survive. And so you'll find all kinds of mutations in domestic breeds of dogs. There's a mutation that causes a dog's snout not to form properly. A dog's supposed to have a long snout. There's a mutation that causes the snout to be short, and the skin kind of hangs off the side. And if you don't clean it, it can get infected and everything, and some people think that's cute. You think about it from the dog's point of view, you think he says, gee, I love having my nose stuffed into my face. That's great. Maybe not. Well, let's talk about poodles. They're cute, but they do have some problems because of mutations that have accumulated in their genome. There are a number of different mutations that can cause disease in poodles. Some of them directly cause disease. Others are sort of a secondary result of, there's a mutation that causes a problem that in itself is not fatal, but leads to another problem that can be. For example, there's a mutation in poodles that causes their hair to grow forever. A dog's hair is supposed to grow so long and then it falls out, and that regulates the hair growth. With a poodle, it just keeps growing and growing. And of course, in the wild, it couldn't survive in the wild. You'd have a big poof ball after a while, right? It can't. I mean, imagine a poodle trying to survive dragging all that hair behind it. It's not going to work. And human beings have to give it a shave from time to time. And if you don't do that, the hair can get in their ears, and they can get infected and get in their eyes, and they can go blind. Just all kinds of problems that poodles have because they've got mutations in their genome. Now, the point is, this isn't evolution at all, because we haven't produced a brand new creature here, right? I mean, it's still a dog, sort of. It's kind of the bottom line of the dogs, but it's still a dog. And we haven't gained any new instructions. We've actually lost some instructions, haven't we? And so it's the opposite of evolution. And so this is how we account for the different breeds of domestic dogs. It's just the variation that God put in the dog kind and mutations, mistakes that have crept in and have caused some problems with these domestic breeds. But it's not evolution, is it? It's in the wrong direction. And so we think, by the way, that the dogs that would have been on Noah's Ark would have been more like the wolf kind, and then through selective breeding, you sort of concentrate those mutations, and then people take care of the dogs with the mutations they like, and you get down to the poodle. But this is not evolutionary because it's in the wrong direction. We haven't added information to the genome. We've lost information from the genome. No new information's been added. Information has been removed. And as a result, you can get these amazing variations in the dog kind, all kinds of variations. And you get a lot of problems when mutations happen, and they can cause disease and so on and so forth. They can cause traits that some people like, but they can be problems for the dog. They really can. And so when I'm explaining this to kids, I like to say that the information in the dog's DNA is kind of like jelly beans. And so you start with the more wild kinds of dogs, lots of jelly beans, lots of different possibilities there. And then through mutations, you lose more and more of those until you get down to the poodle, and then you got some problems on your hands. Okay, that's kind of the end of the line there. Just enough information to keep it alive. It's kind of to make an analogy with cars, you have the really nice cars that have all the extra features, and some of them have even the windshield wipers on the headlights and so on, and all these extra little things that aren't essential, but aren't they nice? The poodle's more like the Kia. It's kind of the bottom line. You remove one part on it, and that's it, right? Well, anyway. But is this evolution? Hardly. But think of it this way. Could you ever turn a dog into a cat by removing information? And the answer is no, because a cat has different information in its genome. It's got information to make a cat. And you can't get different information or new information by removing information. So you see, natural selection and mutations, they can't possibly turn one kind into another. It's not going to work. You can get different variations within a kind, to be sure, but you can't turn one kind of organism into another. And so you see, when we take a look at dogs, for example, or any animal really, and we see how they reproduce, we find, lo and behold, dogs beget dogs. How about that? That's exactly what I'd expect, given what the Bible says in Genesis. And this isn't something that's mystical or storytelling. This is something we can observe today in the present. This is good observational science, the kind of science that makes computers work and puts men on the moon and so on. We can test it, we can repeat it in the present, and we find that it's exactly consistent with what we would expect given what the Bible teaches. And it's not at all consistent with millions of years of evolutionary ideas. Not at all. Now, I should point out that mutations can, under certain circumstances, be beneficial even to the organism. That's right. There are certain mutations that can help the organism survive. But you know what? They're still in the wrong direction to make evolution happen, because they're still losing information. And let's just do one example this evening. Antibiotic resistance. You've probably heard of bacteria becoming resistant to antibiotics. Well, that can happen, but the way it happens is the opposite of evolution. Let me show you how this works. There's several different ways it happens, but all of them involve loss of information in the genome. So you have a bacterium, H. pylori, which causes stomach ulcers, and that's not pleasant. So you take an antibiotic. The antibiotic is absorbed into the bacterium. Now, he's got an enzyme in him that's part of his system. It's something he produces. And what it does is it breaks down that antibiotic into a poison. Okay, so the enzyme interacts with the antibiotic, turns it into a poison. The poison kills the bacterium. You feel better. That's great. There is a mutated form of H. pylori, which, because some of his instructions have been messed up in his DNA, he's lost some information. He lacks the ability to produce that enzyme. And so when the antibiotic goes into him, it just sits there because he lacks the ability to convert it into a poison. And he survives, to be sure, but he survives because of less information. He survives because he's lost some instructions. And so he survives because of devolution, the opposite of evolution. And so what happens then is when you take the antibiotic, all the ordinary bacteria are killed off. The only ones that remain are the mutated form, and then they reproduce, and pretty soon you end up with a resistant strain. And we're seeing that happen today. And evolutionists will say, there you go, the bacteria have evolved resistance. Well, it's bacteria becoming bacteria, and we haven't gained any new information. We've lost information. It's just this is one of those interesting cases where it actually helps the organism survive in that particular instance. And by the way, when these bacteria are in the outside world where there's not a lot of antibiotics, they can't compete with these ones because these ones, that enzyme does something. It helps the bacterium survive normally. So these are a weakened form. It's just that in that particular circumstance, they're better able to survive. According to Dr. Lisle, who's a PhD biophysicist who's been studying mutations for decades, he says all point mutations that have been studied on the molecular level turn out to reduce the genetic information, not to increase it. Isn't that interesting? He says not even one mutation has been observed that adds a little information to the genome. And people get concerned, well, what if they find one? But you see, there ought to be thousands of them. If evolution were true, we're made up of information-increasing mutations. And so they ought to be everywhere. You ought to be able to find them all the time. But we don't. He says there aren't any. Now, there are things that can happen where a section of DNA gets duplicated. That can happen. But do you have any new information? If a paragraph in a newspaper gets duplicated, do you have any new information? Could you learn anything from the duplicated paragraph you couldn't learn from the original? You see, that doesn't help. What we don't find is any process in nature by which brand new instructions are added to the genome of an organism. And so, again, when we take a look at genetics, and we apply good observational science, testable, repeatable in the present, we find it's very consistent with what the Bible teaches. God, having put in that initial information into the DNA of the original organisms back during the creation week, and some of that information has been lost since. But we have no new information. We don't have any more information in our genome than Adam and Eve. We have less. And some of that is just natural variation because you get just you have a unique combination of traits. And some of it's from mutations that have accumulated, and that causes some problems from time to time. I have lower back pain, and that's just a mutation that I've inherited from my father, who inherited it from his father, and so on. Let's talk about information theory then. This is something that's really interesting, and it strongly confirms creation. We've been sort of talking about information, but what is information, and where does it come from, and how is it transmitted? Information can be defined in terms of three parameters, three things. First of all, information always entails a symbolic code system. Okay, so when I pick up a book and I turn to a particular page here, this is the Bible, but it could be any book, and I see hand. I see the word hand here. Now, what I don't see here is a hand. What I see is a word, and that symbolizes a hand. So I get a picture in my mind for what that means. So there's certainly a code system there. Information always entails a language. This Bible happens to be English, but you could pick up one that's in a different language, certainly. The Bible's originally written in Hebrew and Greek and some Aramaic and so on. And then there's a meaning. There's action and purpose. And so for example, when you pick up a cookbook, the expected action is that you're going to make the cake or whatever it is that the book is just telling you how to make. And there's a purpose. The purpose is that you will not go hungry, that you will survive, you'll be able to eat. And so there's always an action and a purpose that's expected of the recipient. Now, maybe the recipient doesn't act in the way the author intended, but that's okay. The information's still there. There's always an expected action and an intended purpose. And with the Bible, of course, we have that, right? I mean, God expects us to have the action of repenting of our sins, for example, and the purpose is eternal life. And so the Bible certainly fits all those qualifications. But really, any creative book that you'd pick up would have creative information in it. So let's try something here. Could this be information? And it looks like it could be, right? It looks like there might be a code system there. And the way you tell if something has information in it is you have to decode it to be sure. And so it turns out this is information. And I know that because I know how to decode it. And I'm going to share that with you. It turns out what this is Genesis 1 through 5, in symbolic form, you see. That's in the beginning. See the clipboard there? In the beginning, God created the heaven and the earth was without form and void, and darkness was over the deep, and the Spirit of God was hovering over the waters. And God said, let there be light, and there was light. And God saw the light that it was good. I like the good symbol. Yes, okay? So that is information, isn't it? Because it fits all those criteria. It's a symbolic code system. There's a language convention. There's a grammar and a structure. And it has expected action and meaning. There's meaning to it. It means something. Now, it turns out that whenever you have information, certain laws of nature apply. Just like when you have energy, the law of conservation of energy applies, right? Which says you can't create or destroy energy. The amount of energy in an isolated system is constant. That's a law of nature. It applies to situations where you have energy. When you have information, there are laws of nature that apply. And let me give you two of them here. One of them is this: there is no known law of nature, no known process, and no known sequence of events which can cause information to originate by itself in matter. So Dr. Werner Gitt, one of the world's experts on information theory, he points out that in all cases where we see information, it's never spontaneously generated just by matter. You sort of know that, right? You know that if you find, a book and it's got creative information in it, you probably would not conclude, well, this was produced by an explosion in a typewriter. Just a natural process, right? You wouldn't conclude that. Not if it has real information in it. If it was just garbled text, then you might conclude that, but not if it has meaningful information. Well, where does information come from then? Well, here's what Dr. Gitt says. He says, when its progress along the chain of transmission events is traced backwards, every piece of information leads to a mental source, the mind of the sender. Now, what he's saying there is that information can be copied even by non-mental processes. A Xerox machine can copy information, and it has no intelligence at all. So it doesn't take intelligence to copy information, but it does take a mind to produce information. And therefore, whenever you find creative information, it might be a copy of a copy of a copy, but ultimately it'll go back to a mind in all cases. And you know that. You pick up a book, again, you don't think it's an explosion in a typewriter, you say, somebody wrote this book. Maybe not this exact copy. This was probably made by a machine that makes lots of them simultaneously. Where did it get its information? From a computer. Where did that computer get its information? From another computer, and so on and so forth. But ultimately it came from a mind in all cases. That's obvious, isn't it? It's a law of nature, and it's a rather obvious law of nature. Well, the interesting thing, of course, given that information always comes from a mind, is that we have in DNA information. Yeah, all the instructions to make you are encoded on that molecule. That's a lot of information. Now, where did you get the information in your DNA? You got it from your parents. It's been copied from them. And they got it from their parents. And they got it from their parents. And so on, all the way back to Adam and Eve, and they got it from God. It comes from a mind, the mind of God. So you see, the laws of information theory confirm biblical creation because it makes perfect sense. God created those first instructions, that first information. It's been copied many times since creation. Some of it's been lost since creation through mutations. But we haven't gained any new information because that's not possible according to the laws of information theory. So this idea that the information in DNA has gradually accumulated and increased over millions of years, according to the laws of information theory, that's not possible. Evolution is not possible if information theory is right. And it appears to be. At least it's confirmed in all of our experiences. And you know what? In their heart of hearts, evolutionists know this. They know that information always comes from a mind. And I can prove this because I did a little social experiment some years ago. I have a blog, and this wonderful article appeared on my blog entitled On the Origin of Articles by Means of Natural Selection and so on, if you get the Darwinian reference there. The article is, what happens, this article tries to persuade you that articles have no authors. In fact, it tries to persuade you that even it has no author. And it goes through and it gives all these wonderful evidences about, it tries to persuade you that articles are actually just a collection of typos. Most of these typos, of course, make the article worse, but occasionally a typo makes an article better, and that's preserved and passed on, you see. The typos that make the articles worse, those articles are thrown away and discarded. And so the idea is that nobody writes articles. Articles are slowly, over millions of years, accumulated typos, making them better and longer and so on. And there's lots of good evidence for this because, for example, we find that certain words, like the word "the," are found in almost all articles. Now, that proves that they're descended from a common ancestor, right? Because how else would they have that feature in common? Well, anyway, the funny thing was not so much the article, but evolutionists. See, I allow people to comment on my blog, or at least I did. I had to shut that down eventually, but I allowed evolutionists to comment on it, and they got on there, "Well, we know you wrote this, Dr. Lisle." And I said, "How? Did you see me write it? No, you just have faith that I wrote it? What's up with that?" And you said, well, we know you wrote it because, and they gave this and that and the other. And I said, well, how do you know? Did you see me write it? Do you have any scientific evidence? Do you have any scientific evidence that I wrote this? Well, I'm sure I could trace back your IP address and so on. Have you done that? No? You're just taking it on blind faith? Well, I mean, that's okay. I mean, you have the right to believe that way, but keep it in church, all right? They could not refute the idea that this article came about by chance without simultaneously refuting evolution, and I think they knew it on some level. You see, the reason they knew somebody wrote this is because they know information it always comes from a mind. It doesn't come about by chance. SETI is another example of this, the search for extraterrestrial intelligence, these radio signals, listening for alien signals from space, right? Radio telescopes that they have. They haven't heard any. I don't think they will. But you need to understand there are lots of radio signals in space. Stars give off radio signals. It sounds like static, but yeah, stars emit radio, so does the sun. And now, with all these radio signals, natural radio signals out in space, how would you distinguish one from an intelligent civilization if there were such a thing? Well, the answer is that signal would have information in it. Yes, if we got instructions from space on how to build a warp drive and we built it and it worked, we'd say, wow, there's evidence that there's intelligence out there. I would accept that as good evidence. But you see, the only reason that works is because information always comes from a mind. And yet in DNA we have information, and the very same scientists that work at SETI would say, oh, well, no, that information comes about by chance. But you see, in their heart of hearts, they don't really believe that, or that program wouldn't exist. Let's talk about geology now, earth science. I think one of the first little myths I have to blow up here is the idea that these rocks have been proven to be millions or billions of years old by radiometric dating. You've probably heard of that. And a lot of people have misconceptions about that. I mean, it's amazing the amount of assumptions that go into certain scientific guesswork, basically. People have the misimpression that, you just hold up the rock and you scan it with your tricorder and it just tells you the age, right? But it doesn't really work that way. Let me show you how this is supposed to work so you can see why it really doesn't. The way it works is there's certain atoms in nature. We're all made of atoms. Certain atoms are unstable, which means they will change spontaneously into other atoms, and that's radioactivity. So, for example, uranium-238 is radioactive, which means it will spontaneously change into this next atom, which changes into the next one, and so on. And they'll emit particles that can be detected as they do this. And in fact, too much radiation can be harmful to you. But with uranium, it happens at such a slow rate, it's not terribly harmful. And it goes all the way down to lead-206, and lead-206 is stable, which means once you're lead-206, you're always going to be lead-206. But the rest of these are radioactive. Now, this happens at a known rate. We know the rate at which this happens. We can measure that today, and it's a very slow rate. And so the idea is if you had a chunk of solid uranium and you waited long enough, eventually it would be part uranium, part lead, with part of the intermediate elements as well. And if you waited long enough, eventually it would be all lead, right? And so the idea is we know the rate at which this happens, and you can use that like a clock to date the age of the rock, right? And thereby date the age of the earth by collecting a lot of different rocks from various parts of the earth. And that makes a lot of sense, right? I mean, if I find a rock and it's got so much uranium and so much lead in it, I could do the math and work it backward to figure out when it was all uranium, right? But how do I know it was all uranium to begin with? Maybe it had some lead in it to begin with. You see the issue there? In fact, if it started out with this amount of lead, the rock could be brand new. Maybe it started out just like this. How would you know? And by the way, evolutionists do not assume that the rock was all uranium to begin with. They do assume it had some lead in it to begin with. Well, how much lead should we start with? Well, you tell me how old you want the rock to be, and I'll tell you how much lead to start with. You see that? And don't get me wrong, there's ways they try to estimate that, but ultimately it's an assumption. You don't really know how much lead it started with. And so that's one of the problems with radiometric dating, a problem of initial conditions. You can think of radiometric dating a bit like an hourglass. And so you have the uranium turning into lead is like sand going from the top chamber to the bottom chamber. Now, hourglasses can be very useful for measuring time if you know when they started. You'd say, well, this one's been going for a half an hour. It's an hourglass. It's been going for half an hour. Maybe not. Maybe it was on its side, and already most of the sand was in the bottom chamber, and then just a minute ago somebody started the process, you see. You can't assume that all the sand was in the top chamber to begin with. Or maybe somebody added sand when you're not looking. That could happen. Uranium is leachable in salt water. It can actually be extracted from the rock. That can happen. Or maybe the throat of the bottle changed size. Now that's probably not too realistic for an hourglass, but it could be that the rate at which radioactive decay happened in the past was faster than it is today. We don't know a whole lot about how radioactivity occurs. We know something about it due to quantum mechanics, but there are a lot of unanswered questions. And in any case, these are three of the big assumptions that are involved whenever anybody tries to make an estimate of the age of a rock. And by the way, it is an estimate. People talk about measuring the age of something. You can't measure the age of something scientifically because science involves what you can measure and observe in the present. And when you talk about how old something is, you're talking about a past history. That's not a science question. That's a historical question. You can use scientific techniques to make a guess, but that's what it's going to be, a guess. And there are assumptions that are involved. And the real kicker is number 2. We actually think that number 2 is just dead wrong because, well, for a number of reasons. But for one, we now know that certain types of radioactive decay can be sped up. In fact, some types can be sped up by a factor of 1 billion. Yes, we can make certain types, in the laboratory, we can make certain kinds decay faster by a factor of 1 billion, the rhenium-strontium, or the rhenium-osmium reaction, for example. And so if we can do it, God can do it. It might have happened in nature. Maybe during the flood year, for example, God might have accelerated the radioactive decay rates as one mechanism to start the flood. That would do it because it creates heat in the process. Anyway, the bottom line is this. We know radiometric dating doesn't work because we've tested it on rocks of known age. When Mount St. Helens erupted back in 1980, and there have been some subsequent eruptions, it produced brand new rocks. And when the rock hardens, that's supposed to set the 0 point of the radiometric clock, okay? So we took rocks that are brand new, their true age is 0, and we sent them in and had them radiometrically dated by secular labs, so we couldn't be accused of bias. We didn't tell them that they were from a recent volcano. We just said, how old do you think these rocks are? And we had them radiometrically dated, and they came back with ages of hundreds of thousands to millions of years on rocks that we know are brand new. And you say, well, that's an isolated incident. It's not. You go to Hawaii, you take a rock from Hawaii, and you date it, you will get millions of years. Brand new rock, you can take it right, you can put your stick in there, right into the magma, let it harden on the end of your stick, stick it in, you'll get millions of years, consistently. So you see, radiometric dating has been shown to not work on rocks of known age, and yet secular scientists assume it works on rocks of unknown age. Is that logical? If I gave you a calculator, Merry Christmas, you put 2 plus 2 equals, and it gives you 57,215. I say, well, don't worry, it works on big numbers. I think you say, well, I don't know. I mean, if I can't trust it in small matters, why would I trust it in large matters? There's a biblical principle there, right? What about carbon dating? Carbon dating, we actually think, is much more reliable than these other methods for a number of reasons, but one of them is this. When we carbon date things of known age, we tend to get the right answer. Not always, but usually. And so I have a little more confidence in carbon dating. Now, it's not infallible either. But the interesting thing about carbon dating is it's our friend. Carbon dating always gives ages that are consistent with biblical creation. It never gives millions or billions of years, even on things that evolutionists believe to be millions or billions of years old. I'll come back to that. The way it works is this. Most carbon is C12, but there's a variety of it, C14, which is unstable. It's got 2 extra neutrons, and that makes the nucleus unstable, and it will tend to decay into nitrogen. C14 is produced in the upper atmosphere when cosmic rays bombard nitrogen atoms, and that makes the C14. And then when you're alive, you breathe in, right? You breathe in air, and you eat food, and some of that food has C14 in it. So most of what you're made of is carbon-12 and water, but a lot of carbon-12, but you have a small fraction of C14 in you. So you're all slightly unstable. How about that, right? You knew that. And when you're alive, even though that C14 is constantly decaying back to nitrogen, which it does continually, when you're alive, you're constantly eating more food and you're breathing. You're exchanging carbon with your environment. And so you replenish that C14, right? You take in new C14. And so when you're alive, that ratio remains constant until you die. And when you die, you're no longer eating, you're no longer breathing, the C14 just decays away. And so the idea is, by measuring the C14 to C12 ratio in something that's dead, you can tell how long ago it died. And it tends to work pretty well. It tends to give us the right answers, at least within an order of magnitude of the biblical timescale. So it's pretty good. The interesting thing I find is that no matter what you test it on, you get thousands of years. Even things that evolutionists believe to be millions of years old or hundreds of millions of years old, like coal beds. You take a chunk of coal, carbon date it, you get thousands of years. Every time. You can't find a chunk of coal on Earth. I'll make this challenge to you. You cannot find a chunk of coal on Earth that doesn't have C14 in it. Isn't that interesting? And yet they're supposed to be hundreds of thousands of years old. That doesn't work. The half-life of C14 is only 5,700 years, which means if the entire Earth were made of nothing but C14, after 1 million years, you would not have a single atom of it left. It would all have decayed away into nitrogen. And so the fact that we find it in things that are allegedly very old tells me they're not really very old. We've even found C14 in diamonds that secular scientists believe to be 1 to 2 billion years old based on these other radiometric dating techniques, which have been shown to be unreliable. You carbon date them, you get thousands of years. There are hundreds of physical processes like that. This is not an isolated incident. There are all kinds of processes that limit the age of the Earth to much less than the billions of years you tend to hear in public schools and in the media and television and movies and so on. For example, the rate at which salt fills the ocean. Rivers, even fresh water, has a little bit of salt in it. It picks up salt from the continents and it dumps it into the ocean. And the water just evaporates, but it leaves the salt. Salt doesn't evaporate. And so the oceans are actually getting a little bit saltier every year. Every year, 450 million tons, if you think of all the rivers on all the Earth acting all the time, 450 million tons of new salt is dumped into the ocean every year. Oceans are constantly getting saltier. If you run the equation backwards, we know the rate at which it happens. Even being very generous to the critics, you find that if you run it back 62 million years, you can't go beyond that because this would be the amount of salt in the oceans. Once you get beyond 62 million years, it would be zero, you see. And that's an upper limit because you can't have less salt than no salt, right? So that's an upper limit. And if the ocean started salty, then they're much younger than that. So you see, that's very consistent with the biblical age of 6,000 years. The secularists believe the oceans are 3 billion years old. But you see, they can't be because the rate at which salt fills then puts an upper limit of 62 million years. The rate at which mud accumulates on the ocean floor, we can measure that too, 20 billion tons a year. You could maybe get rid of a little bit of it with plate tectonics, but at maximum, that'll get rid of 1 billion tons a year, leaving the other 19 billion tons to simply accumulate. How long does it take to get Earth's current amount of mud on the ocean floor? It takes less than 12 million years to get the current amount. And that assumes there was no worldwide flood, which would deposit a lot of mud very quickly. So again, that upper limit is consistent with the biblical time scale of a few thousand years, and it's wildly inconsistent with the secular time scale of billions of years. Human population. How long does it take to get Earth's current population of human beings from 2? It doesn't take anywhere near millions of years. It's very consistent with the biblical time scale of a few thousand years, 4,500 years. Remember, humanity had to start over with Noah and his family. So we've been able to measure population growth, or at least we have estimates of it over time. It's very consistent with the biblical time scale. And I realize you have to include for increased mortality rate in the past and so on, but when you do that, it's very consistent with what the Bible teaches. But the best evidence, hey, we got the birth certificate of the universe. We have an eyewitness testimony of how the earth was made and when, and God says he made in 6 days. And so what it really comes down to is the secularists say the earth is billions of years old, take my word for it, but God says I created in 6 days, take my word for it. He's the only one that really knows in terms of his own authority. Well, what about these fossils that we find? I was always given the impression that fossils took a long time to form. But you know, we find fossils all over the world that often are buried under what seems to be catastrophic circumstances. Here you have an ichthyosaur. This is a marine reptile. It's air-breathing, but it's a marine reptile that evolutionists believe lived millions of years ago with the dinosaurs and so on. But you see this thing was buried and fossilized in the process of giving birth. You see the baby ichthyosaur being born there. They're born tail first because they're air breathers and they have to swim to the surface and get their first breath of air when they're born, which is kind of neat. Here's a fish buried in the process of eating another fish. And so you see, this seems to be something that happened pretty rapidly. It's not something that's just slow and gradual. In fact, you sort of know that. You know, most things don't become a fossil at all. Most things decay, right? You've probably seen a dead animal on the side of the road. We'll do a little experiment on our dead cat, Earl, okay? We'll leave him there by the side of the road and just see what happens. Is he going to slowly fossilize over millions of years? Well, let's wait a little while. Day 3, smelly dead cat on grass, okay. Wait a little while longer. Day 9, very smelly dead cat on grass. Day 20, parts of Earl missing. Day 38, more of Earl missing. Day 65, Earl's missing. Yeah, where's Earl? Well, yeah, things decay, right? They get recycled back into the environment. They're picked apart by scavengers and so on. In order to fossilize something, you must bury it. You must somehow protect it from the environment. Otherwise, it's going to decay. And even there, I was given the wrong impression. I was told the fish dies, because we find fossil fish everywhere. I was told the way this works, the fish dies, it sinks down to the bottom, it's slowly covered with sediment over millions of years. But you see, if this layer of sediment here were millions of years after that layer, the top of the fish would have had plenty of time to decay. Obviously, the whole fish had to be buried quick. And fish generally float anyway, right? In any case, when you see those specials, where they go down National Geographic or whatever, where they go down to the ocean floor, I love looking at those things. You don't just see billions of dead fish waiting to fossilize. The ocean's active, and there's scavengers that pick them off and so on. Now, if you want to form a fossil fish, here's how you do it. You go home to your aquarium, and you take some concrete and dump it on your fish. I don't know about here, but this is still legal in Texas. Anyway, it's going to bury the fish, and it's going to permineralize then. Usually the soft parts of the fish have time to decay away. There's enough bacteria they can eat away the soft parts. But then the hard parts permineralize. The minerals move through that water, and they fill in all the little holes in the bone. Bone is light and kind of porous, but a fossil's heavy because all the minerals have come in and filled in the little holes in the bone. And so you'll end up with a stone that looks like a bone. That's what a fossil is. What about the kinds of fossils we find? I've seen textbooks like this. There you go. See, evolution of the horse. And I'm thinking, I see different varieties of horse. This is what I'd expect as a creationist, right? We got different varieties of dog. We got different varieties of horse. And you say, oh, look, but some of them are very small and some of them are large. But that's totally irrelevant because even today these are both adult horses. They're just different breeds. We have variation within a kind today. And you say, oh, but the feet were a little bit different. Well, yes, they were. And some varieties have gone extinct, but that's okay. These are just horses, though. And they line it up like, this turned into that, turned into that, turned into that. You don't know that. Just because things can be lined up in a sequence doesn't mean that one actually, it was the ancestor of the other. Not that it would be a problem if it were, because they're still horses. But I just think it's interesting, because the rib cages don't line. If you line it up by number of ribs, the order's different. Yeah, I forget what it is, but it's like 13 versus 18, then back to 12, and then it's something like that. It's not in the same order. But we'd expect variation within the horse kind. We have lots of that today. Why wouldn't we expect that with some of the extinct varieties as well? Not a problem at all. What about the rocks in which these fossils are found? I was given the impression rocks take millions of years to form. Well, here I have a set of car keys embedded inside solid rock. I don't think that took millions of years to form. I really don't. Here we have a man-made clock embedded inside solid rock. How about that? I guess we know when it happened. But that's about it, right? That's the only rock we know when it happened, right? At least when the clock stopped. What about all these layers of rock? There's a person down there for scale. Surely it took millions of years to lay down those layers, right? Well, I got news for you. Those layers did not exist before 1980. They were all produced in the Mount St. Helens eruptions. It produced a pyroclastic flow and deposited brand new sedimentary rock layers, one on top of the other, all with one rather piddly little volcano. Pretty small by volcano standards. And it cut out, one of the subsequent eruptions cut out a canyon 1/40th the scale of the Grand Canyon in a matter of hours. It doesn't take millions of years to form canyons. Not at all. And the fine layers that they find in there that they used to say, well, this is 1 year after the next. You find these like in the Grand Canyon, and they say, see, this is 1 year, the next year, the next year, the next year. These are annual layers. Well, those are all produced in that Mount St. Helens eruption. They're not annual. They're layers. They're not annual. So, well, there's more I could do on this, but again, we'd be here millions of years. So let me sum it up. When we take a look at geology, earth science, we find when we apply good, consistent observational science, it's very consistent with what God has said in His Word, and it's not consistent with millions of years of gradual process. It looks like catastrophe. When we take a look at our planet, it looks like our planet has been hit with a worldwide flood. And that's, of course, exactly what we read in Scripture. And so we need to keep in mind that these rock layers are not evidence of evolution or millions of years. They're evidence of God's judgment. What the rocks are really telling us is repent. They're telling us that God is just and He will judge sin. He's done it before with water. He's going to do it again by fire. Are you ready? That's really what it comes down to. Well, again, your pastor gave me an hour, but was that a literal hour or millions of years? Well, let me again remind you of the resources. We had some resources for the conference here, but we sold out of just about everything. But you can get all of these on our website at icr.org, and I would encourage you to get these resources. Everything I talked about today is in this book, Creation Basics and Beyond. This is written by all of our staff scientists at ICR, and it is a really neat resource. It's just it gives you the basics of everything that you need to know to really defend the faith well in the area of origins. Fantastic resource that I'd encourage you to get, Creation Basics and Beyond. We may have like 5 copies left. So I don't want to see everybody rushing out. This is not survival of the fittest here, right? But there might be a few copies left. And we can also back order it for you, or you can get it off the website. We can do it either way. Joel will probably be happier with me if you get it on the website, but either way. And The Ultimate Proof of Creation, if you want a really good, rock-solid argument for biblical creation, this is the book you want to get. And I would highly encourage this. If you have students who are going to go off to college, this is what they need to get. This is going to show you how to think right, how to think biblically, how to expose errors in reasoning. And another book along the same lines, Discerning Truth, how to spot logical fallacies in these evolutionary arguments that evolutionists tend to make. They tend to be full of errors in reasoning, logical fallacies. We have books on various topics, very specialty topics. My specialty topic is astronomy. Taking Back Astronomy is my apologetics resource, showing you how the universe declares God's glory. And so it's a really neat resource. And lots of beautiful pictures. Some folks have thought it's a children's book because of all the pictures. It's not. It's for adults. My theory is adults like pictures too. And that's one of the ways the universe declares God's glory, is its beauty. We have DVDs as well that you can check out on our website. The Created Cosmos, again, we might have 2 or 3 back there. This takes you on a tour of the universe. Really neat. And all from a biblical perspective. And so this is not a lecture. This is a movie that's very immersive and enjoyable, I think. The Secret Code of Creation, how God has built beauty into numbers. If you have young students who say, well, I don't really care about math, have them watch this. No promises, but I have had people say, I used to hate math, but now I see God's mind in mathematics. There's a beauty in it that I didn't realize there was there. This is really neat. I don't want to spoil it for you by telling you too much about what it's about, but there is a secret code that God has built into mathematics. So those are just a few of the resources you can get on our website. We do have some free stuff for you here, and one of the things that you can sign up for are Acts and Facts magazine. This is a free resource I'd encourage you to get, and it's a monthly magazine that just is going to, I think, build your faith, and we have our scientists write in it, and we have some articles on theology as well. So I think that's really going to bless you. It'll cover some of the things we talked about this evening and just keep you up to date on the latest research in creation and origins. So again, totally free. There's no catch on that. And again, check us out on the web as well. ICR.org is our main website. And you might want to check out my blog, too, if you want to see how evolutionists respond to the fact that articles have no authors. It's really amusing. So I want to thank you very much for having me out to speak. I've really enjoyed it. I hope you have, too. Thanks.